8.1?
No, but let's do it anyway.
Lesson 8.1. Turn with me to page. Let me find it here. .422. That's where we're going to be today. We're going to start with just giving you a little situation that we're going to discuss.
I need you to sign this before.
Okay.
Oh,
You're going to purchase 4 rabbits. Rabbits are going to double in number each month. I mean, that's not true, but we're going to go with that for our story, okay? So, if you purchase 4 rabbits, that's month 0. Okay? After 1 month, how many rabbits do you have? After 2 months? After 3? Okay. After 4? After 5? Okay. After 6? After 7? Okay. After 8? After 9?
2048.
And after 10?
4096.
Okay. So after 10 months, we've gone from 4 rabbits to 4,096 rabbits.
Not how I talk, Carter.
What are we doing here? What are the numbers doing, Carter? They're getting bigger. Are they getting bigger? Let's talk about this situation. I'm going to purchase 4 ducks. And I'm going to add 2 ducks each month. So at the end of 1 month, how many do I have? And the end of 2 months. And 3 months. And 4 months. And 5 months. And 6. And 7. And 8. And 9. And 10. Okay. These numbers are getting bigger too, right? You agree? So I need you, when you say the numbers are getting bigger, I need you to be a little more clear.
How they're getting bigger.
Those are multiplying by 2 every time these are adding by 2.
Okay. So the difference between the number of rabbits from here to here is what?
4.
The difference is 4. But when I go here from 8 to 16, the difference is 8. And from the 16 to 32, the difference is?
They're multiplying by 2.
The difference is multiplying by 2 each time. So these are growing. Are these growing?
Yes.
These are growing faster, right? Much faster. What's the difference between these two? What's the difference between these two? 2. These have the same difference all the way down, although both of them are growing. Okay. So if we were to graph this one, let's graph the rabbits here. And you don't have to graph it on your paper. You can just watch what I'm doing here. I'm going to move it over here. Okay. Here's rabbits. Let's see if I can get everything on here that I want you to be able to see at the same time. Okay. At time 0, how many rabbits did we have?
4.
Okay. After 1 month, how many rabbits?
8.
After 3 months. Okay, what's the next one? 32. Did I skip one? That dot's supposed to be there, right? Ignore that one. So this would be 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay? That's the rabbits. See if I can zoom out so you can see a little bit more of it. Okay? So this is what this curve looks like. Now let's graph the ducks. 0, how many? 4. Same starting place, right? 1 month, how many do we have? 2 months? 3 months? 4 months? 5 months? What's happening here? What's this line going to look like? This one is linear. It's a straight line, right? Can anybody give me the equation of that straight line?
Y equals 2x plus 4.
2x plus 4. Okay, this is not a straight line. Not at all. This is called exponential. And the equation for this is y equals 4 times 2 to the x power. Now tell me where I got the 4 for this one. In the story of the rabbits, what was 4?
The
Starting point. So that's the starting amount. And 2 is the,
what you're multiplying it by each time.
okay, growth factor is the term they give to that, growth factor. Okay? So over here, we call this the y-intercept. It's still the starting amount, isn't it? And this is the slope, or the rate of change. And in a linear one, the rate of change is constant. Is the rate of change constant here? No, the growth factor is constant, but not the rate of change. The rate of change is doing exactly what the growth factor tells it to do, and it's doubling each time. Okay, so if I give you this problem, y equals 2 to the x power. I want you to make a table and a graph for that. Can you do that on your paper? Do that on your notebook paper. Okay, and when we graph this, did y'all have them start at 1? And then at 1 it was 2, and then it was 4, and then it was 8. Does your graph look like this? Okay. Let's put it in our calculator. Go to y equals 2 to the x power. Hit zoom.
The line's wrong.
6. Okay, any questions on this? Can we do this? Okay, next story. Here we go. You take 10 milligrams of Tylenol. At time 0, your body contains 10 milligrams of Tylenol. Tylenol has a half-life of 1 hour. Do you know what a half-life does? That means in an hour, there's only 5 working milligrams of Tylenol in your body. And in 2 hours, how many would that be? Every hour it cuts itself in half. Cuts itself in half. 2.5. And the third hour?
1.25.
Okay. And the fourth hour? And the fifth hour? And the sixth hour? Okay. Do you think this will ever get to be 0 right here? No. When can you take another Tylenol? How long do they let you go? They'll let you take another one after 4 hours. You still got stuff in you, that's right. And the stuff never goes away. It keeps dividing by 2 and it gets smaller and smaller, but does it ever truly ever go away? Well, because if you have less than 1 milligram in your body, it's not doing you any good. Okay. Now, disclaimer. Here's a huge disclaimer. This story about Tylenol is completely made up. It may or may not be true. Do not take this. Do not take this for the truth. Okay. This is just. I do know you can take another Tylenol in 4 hours. That's why I kind of set the problem up this way. So if you were to take something you shouldn't have, will it ever truly go away?
Abby? What?
I'm recording this. No confessions, okay? So when people test, Kelsey's not here, so I'm recording it for her. When people test for different types of things for employment, a strand of your hair is better than other types of tests that you've seen, because a strand of your hair tells you, well, for Caroline, it'll probably tell you what you had taken over the last 3 to 5 years. Carter probably over the last year. But anyway, that's why they will do that. So, tell me what this is doing. Is this getting bigger or smaller? It's getting smaller. Well, we're going to set it up the same way we set up that other problem. We're going to put the starting amount right here. What's my starting amount? 10. What's happening every time? I'm not doubling. You're multiplying by half every time. So let's put this in our calculator. 10 times 0.5 to the x power. And let's graph. That's what that graph's going to look like. Now look at the bottom. Do you think this is ever going to hit 0? It appears to touch that line because our technology and our eyesight's not perfect, and it's going to appear to do that. But it's like asking this question, does this ever get to 0? No, it doesn't. When a graph gets as close as possible, it continues to approach that line, but it never will touch it. It's called an asymptote. Okay? Let me get this. An asymptote. A line that the graph approaches but does not touch. And this is called decay factor because it's going down. So we have exponential growth and we have exponential decay. And in one, the numbers are increasing and the next one's decreasing. Let me ask you a couple of questions.
So the one up there was growing.
Right. So if I gave you this, tell me about this story. This is a story about ants. Sally started with how many ants?
13.
They something each month. Tripled. Next, you're going to say Jane took blank milligrams of Advil. The Advil did what each hour? Divided by 4 each hour. So if she had 24 at the beginning, how many does she have at the next? 6. And at the next?
1.5.
Okay. Now, disclaimer about the medicine. These numbers are absolutely not accurate. Okay? You have to wait at least 6 to 8 hours before you take Advil. That's what the box recommends. Okay. So we've got the general idea of this, right? Okay, this is what they're going to ask you to do. They're going to give you 2 points. 2, 2, and 3, 4. And they're going to ask you to write the equation for the exponential function that goes between these 2 points. Now, when we did this for linear, we used the slope formula. We found the slope. We put it in point slope. We rearranged. So it's going to be several steps just like before. But let's start here. Here's your general formula. Y equals A times B to the X. Now, you remind me, A means what? Starting point, starting amount. And B is your growth factor or your decay factor, depending on whether you're getting larger or smaller. Step 1, write this down with me. Replace X and Y with an ordered pair. So I'm going to use the first ordered pair. Step 2, solve for A.
So when you say replace X and Y with ordered pairs, that's just as we use the
Yes, I put this one here and this one here. Okay. Now, use the general formula again. With 3, 4 as your ordered pair and A as 2 over B squared. Now y'all read it and think about it before we do it. We're going to go back to that same formula, but in place of Y, I'm going to use the 4. In place of A, I'm going to use what I solved for, and in place of B, in place of X, I'm going to use the 3. So you ready for me to write this down? What's it going to say? 4 equals 2 over B squared times B to the 3rd. Well, the only math that I see you can do here is cancel those B's. How does that sift out?
Okay, can you explain that to me a little bit before we keep going?
This is step 3. We're going to go back in here. We're kind of doing like a system of equations. We're getting everything, we're getting A solved for. Yeah, so I'm going to drag it over here and put it in its place. Does that make things better? Okay. Now, then step 4 is simplify. Step 5 gives me 4 equals 2B. So now I solve for B.
So when you simplify, you did.
That's when I took care of these. is step 6. Find value of A using B equals 2. Okay? You found out what B is, so now you can go back and you can say, oh, 2 over 2 squared is A. 2 over 4 is A. A is really what? 1/2. And those are the only two things I'm really looking for here. I'm looking for A and B. Because my answer is going to be y equals A.
Okay.
Don't multiply those together and say, oh, look, that's not 1 to the x.
Do you put, like, if you're writing it out, do you put a parentheses around it?
I would. Okay, so do you think you can repeat these steps? That's the most difficult part of the lesson, okay? So on page 426, it's 2 through 34 even for today.